Vectors in one dimension. So vectors in one dimension simply means that if we are dealing with horizontal vectors, we're only going to deal with horizontal vectors. And also, if we are dealing with vertical vectors, we are only going to deal with vertical vectors. So in this video, we are going to learn how to add and subtract vectors in one dimension. So let's say, for example, we are given the following three vectors. To say now, an object is pulled by a force of 5 newtons to the right, and secondly, it is pulled by a force of 2 newtons to the right, and lastly, is pulled by a force of maybe 3 newtons to the left. So this problem here, it can also be given with a force diagram. Let's say, for example, they say this is a block here, and then this block here is pulled by a force of 5 newtons to the right, and the other force of 2 newtons to the right, and the other force of 3 newtons to the left. So if you want to add these vectors, you can add these vectors by using what we call a schematic diagram, and we can also add these vectors by using calculations. So if we want to add these vectors by using calculations, that means we must draw a free body diagram for all the vectors that we have. So in this case, our free body diagram will be this dot here, and then we're going to indicate all the vectors with their direction. So the first vector is 5 newtons to the right, so we're going to write it is 5 newtons going to the right. And then now the second vector is 2 newtons to the right also, so it's 2 newtons to the right. And then lastly, we have a vector of 3 newtons to the left. 3 newtons to the left. So if we look at this schematic diagram of ours, we have forces that are going to the right, and we also have forces that are going to the left. So this direction of ours here, right and left, we can represent them by signs. For example, we can say now the direction that is going to the right, it is going to be positive, and the direction that is going to the left is going to be negative. Remember, it is you who can choose the sign of the direction. You can either decide to choose now your left is positive and then your right is negative. So it is really up to you. So let's say now we have selected the right to be positive, and then we have to find the sum of all these vectors. So we're going to say now the sum of the forces that are acting on this object here, we're going to add all the forces. So we're going to say the resultant force, which means the sum, is going to be force number 1 plus force number 2 plus force number 3. But now when we substitute these forces, we must put in the sign because the sign will indicate the direction. So if we substitute now force number 1 is 5 newtons and is going to the right. So that means we're just going to keep it positive because we chose right as positive. And then the force of 2 newtons is also going to the right, so it's going to be positive. And then lastly, if we look at the force of 3 newtons, the force of 3 newtons is going to the left, so it's going to be negative. So after we do what? We add all our forces using the direction. We can just put everything into the calculator to get our resultant force. So this will be 5 plus 2, which will give us 7. Then 7 minus 3 will give us 4. So that means the resultant force will be 4 newtons. But if we get the answer of our resultant to be positive, this indicates that the direction of our resultant force will be to the right because we have selected right as positive. So the answer will be 4 newtons right. Because a vector is what? Is something that has magnitude and direction. And in this case, the vector that we have is a force. So a force will have a magnitude and will also have a direction. So this is how we will do this kind of a problem using calculations. But now, if we want to solve the very same problem using a schematic diagram, we will have to do what? We have to know how to draw a vector. So if you want to draw a vector can be drawn by something like this. You have an arrow, and then that arrow must have a direction. So the distance from what? From the starting of this arrow to the finishing of the arrow, it will indicate the magnitude of the vector. And then now this arrow of our vector, it will obviously indicate the direction. So now, if we also look at this arrow of ours, this arrow, it has a starting point here, and then the starting point is called a tail of the vector. And then this arrow that indicates the direction is called the head of the vector. So I hope you understand what is a vector and then how to schematically represent it. So now you represent it with an arrow, and then the distance from the starting point of the arrow to the finish point, it represents the magnitude. And then the arrow here will indicate the direction of the vector. So let's say, for example, now we want to represent this vector of 5 newtons. Remember, now we're just going to say this is going to be from starting point to that point. And then the arrow here will indicate the vector is going to the right. But now the distance from this point to that point will be 5 newtons. Hence, this will be the vector of 5 newtons to the right. Then if we want to represent the vector of 2 newtons, we're going to say, okay, 2 newtons is also going to the right. So the magnitude here will be 2 newtons, and then this arrow will indicate the direction. Then lastly, if you want to represent the 3 newtons, the 3 newtons is going to the left. So it's going to go in the direction of the left, but now the magnitude will be 3 newtons. So you represent the vector by showing the magnitude and the direction. So let us now apply what we are saying to actually solve this problem. So if we want to solve this problem, we must be accurate. That means now we must know what is going to be the magnitude of our vector. In this case, we see the magnitude of our vectors is in newtons, and then if we want to make them to be accurate, we need to use a ruler, and then in our ruler, we only have 2 units. For example, at the top here, it can be centimeters, and then at the bottom, it can be millimeters, depending on what type of a ruler you are using. But if we look at my ruler here, my ruler does not have units, so I'm going to just assume that all the units that I have here is just newtons. But let's assume that in your case, we are using your ruler that is having centimeters and millimeters. So you will have to apply what we call a scale so that you will be able to represent these 5 newtons using centimeters. So you will say, for example, I'm going to use a scale that 1 newton is the same as 1 centimeter in my rule. And then how are you going to represent, for example, the force of 5 newtons? We can see now the force of 5 newtons is starting, maybe you can have a starting point here, and then it's going to the right, and it has 5 newtons. So you're going to represent 5 newtons with what? With 5 centimeters. So you're going to say you have 1, 2, 3, 4, 5 centimeters. And then this line here will represent the magnitude of your vector, which is 5 newtons in this case. And then we represent it with 5 centimeters, for example. So you will say now, your vector has what? 5 newtons, but now it is going where? The direction is going to the right. So now, if you want to add the vectors, we use a method that is called head to tail method. So head to tail simply implies that after you draw the first vector, you're going to draw the second vector from the head of your previous vector. So if we want to draw the second vector here, that means the second vector is going to start where the first vector has ended. So the first vector ended here, which is the head in this case. So the tail of the second vector will be from that point moving on. So now if we look at vector number 2 here, it is having 2 newtons to the right. So we'll say now we are at our starting point, which is at the head of the previous vector, and then we're going to measure what? 2 units to the right. So this is going to be 1, 2. So if we also want to plot our vector, we're just going to join the lines and indicate to say now the magnitude of this vector is 2 newtons. And then we also indicate the direction to say it is going from where? It's going to the right. So the arrow will indicate the direction. And then now, if we want to represent another vector, that means on top of what? Of the head of our vector, we're going to put a point, and then we're going to draw another vector. Okay. Can you see that if I just want to draw on top of this vector, my vector will lie on top of another vector, and then that will be difficult for me to measure it, okay? You can just also try to plot your vector maybe at the bottom here to say now just a small distance to say my first vector or my previous vector, it has ended at this point. So I'm going to draw my third vector from this point and then using the direction as provided. So the direction of our third vector is going to the left and it is having 3 newtons. So we're going to say now we have 1, 2, 3 in the left direction. So we're going to plot now to say our vector is having this magnitude of 3 newtons. But now the direction we know is going to the left. So now, if we want to get the resultant force from our schematic diagram, the resultant force will always be from the starting point to the finish point. So in this case here, we have our starting point to be at what? At this point here. This is our starting point here. And then our finish point is going to be at this point. So the distance from the starting point to the finish point, that will be the magnitude of our resultant vector. And then also the direction will be from what? From the starting to the finish point. So let's now draw the resultant vector here. We'll say the resultant vector will be from what? From the starting point of which we have started at this point here. And then we have finished or we have ended our journey at this point. So at this point where we have ended our journey, that will be the what? The direction. The arrow will indicate to say now it's going in this direction. So but now, how do we measure the magnitude of our resultant force? So we're just going to say now, we use our ruler to say, we already know that 1 centimeter is the same thing as 1 newtons. So we're going to read all the centimeters that we have. So we say now, this is going to be what? It's going to be our 0, and then we have 1, 2, 3, 4. So we see now the magnitude of our vector is going to be 4 newtons. So the resultant vector, the magnitude of our resultant vector in this case is going to be 4 newtons. So also we know the direction because the direction is from the starting of the vector to the finishing. So it's going to the right. So we'll therefore say now, therefore, the resultant force of this problem is going to be 4 newtons. And then it's going to have which direction? It is going to the right. Remember, I started here and then it finished there. So it's going to the right. So we'll get the same results as we used the calculation. Remember, when we used the calculation, we also got that our resultant vector will be 4 newtons to the right. Thank you very much.